guys, concept of moles and stoichiometry, lesson 1. I am your teacher Imtiaz. First of all, the mole can be defined as in different ways. So I have compiled 3 different ways for you guys regarding the definition of mole. The number 1, is the atomic mass, molecular mass, ionic mass, or formula mass of a substance expressed in grams is called mole of that substance. Very important. Atomic mass, molecular mass, ionic mass, or formula mass. You guys must have learned about what is atomic mass. Okay, so either it is atomic mass or that refers to the masses of atoms. Either it is molecular mass, which refers to the mass of molecules, or ionic mass, which refers to the masses of ions, or formula mass, which refers to the mass of ionic compounds, not ions, ionic compounds. It is very important. Okay, these are the basic terms, and I will share a short course regarding these basic terms also with you guys. Okay, so you guys go through that course also, and also share with you the study material. Okay, so concentrate yourself, because the mole is very important. It is a basic of chemistry, if we would say, from basic to if we would like to study chemistry in advanced level. The concept of mole is again very important, as well as in basic chemistry concepts. So again, what is the mole? The atomic mass, molecular mass, ionic mass, or formula mass of a substance. Expressed in grams is called mole of that substance. Simple. Okay, we will discuss certain examples. You will understand it easily, inshallah. Okay, now, or in other words, we can say the amount of a substance which contains, very important, which contains 6.02 into 10 to raise power 23 of atoms, molecules, ions, or formula units is called mole of that substance. Amount of a substance, very important guys. Any substance, any pure substance. Here, amount of any pure substance, which can be atoms, which can be molecules, which can be ions, or which can be formula units of ionic compounds. Okay, and contain how many particles? 6.02 into 10 to raise power 23 particles. In terms of atoms, the 6.02 into 10 to raise power 23 atoms. In terms of molecules, the 6.02 into 10 to raise power 23 molecules. In terms of ions, the 6.02 into 10 to raise power 23 ions. And in terms of formula units for ionic compounds, it will be 6.02 into 10 to raise power 23 formula units. That is called mole of that substance, and this quantity is actually equal to the Avogadro's number. Actually equal to Avogadro's number. So the next definition that I compiled for you guys covers this portion also. Okay, you can define either way, either first way, second, or third. The ultimate meanings are same. Okay, so the third definition that I have compiled for you guys is the amount which contains. Okay, you can say it is active or passive manner. The amount which contains Avogadro's number of units. And what is the value of Avogadro's number? 6.02 into 10 to raise by 23. Here at the bottom I mentioned again 6.02 into 10 to raise by 23 particles. So the amount which contains Avogadro's number of units, that is units of what? That those will be atoms for molecules, ions or formula units for molecular compound, or any other unit which is under consideration is called mole. Is called mole. Understand? Is called mole. Very important. I have mentioned here. Check out. What? Avogadro's number 6.02 into 10 to raise power 23 of particles. Those particles can be atoms, ions, molecules, formula units, etc. in 1 mole of that particular species. Atoms, ions, molecules, formula units, molecular ions, all these are actually species. It can be free radicals also. So these are all species. So any species, if it has 6.02 into 10 to raise by 23 of particles, that will be, its unit will be termed as 1 mole. Or simply as I have discussed in the very first definition. What is that definition? You please concentrate on it. Okay guys, what is that definition? The atomic mass, this, molecular mass, this, ionic mass or formula mass of a substance expressed in grams is called mole of that substance. Okay, I'll discuss different examples later on in this lecture. Okay, you don't have to worry, you will definitely get, inshallah, perfect concept about the concept of mole. Okay, now let's move a bit ahead. Let's explain it a bit. So it means we can use mole concept with other terminologies also for different types of substances like elements, molecular compounds, ionic compounds and ions. Normally we have been talking about chemical substances in terms of individual atoms and molecules. Whenever we discuss the atom of hydrogen, the atom of oxygen, the molecule of water, the formula unit of sodium chloride and NaCl. But when we perform certain experiments or we use chemistry in industrial application, we do not typically deal with substances on atomic or molecular or ionic levels. We deal these species with particles in millions, billions and trillions, which can be atoms, molecules, ions or formula units. So if we are dealing something in millions, billions and trillions, then how can we apply the simple atomic masses, molecular mass systems at bigger level in millions, billions and trillions? Like if I would like to say that we have one molecule of water, okay, H2O. You all guys should know that water is H2O. In chemistry we write its formula H2O. Now H2O, if it is one, we can discuss it theoretically, but whenever we have to discuss it practically, we cannot take one molecule of water. We will take a glass of water, we will take a beaker of water, we will take 5 ml of water, 10 ml of water to study different properties of water. So you know those 5 ml can contain millions and billions of water molecules. So how we will deal with their quantity, units of quantity? So here we will apply mole. So now you have come to know that practically we are not going to discuss these quantities at microscopic level. We have to discuss with them at macroscopic level. Okay, so for this purpose we need a unit that relates these quantities, some sort of scale that we can interact with. We cannot interact with at atomic level, okay, at molecular level. As I have given you example of a glass of water or 5 ml of water will contain millions or billions of molecules of water. So, and whenever we have to discuss, we have to study certain properties of water, we have to take it in a reasonable quantity, not a single molecule. So it is very important to give them a certain unit and to understand those macroscopically at a larger scale. Macroscopically mean at larger scale. Okay, so that is why we use mole. Let's take another example. Okay, let's take another example. Like if we go to a grocery shop and we ask him, okay guy, just please give us a dozen of eggs. We normally, whenever we going to buy eggs from market, from grocery shop, we ask the shop owner, please give us a dozen of eggs or dozen of bananas, etc., or dozen of oranges, which is equal to 12. A dozen mean a certain number. Okay, similarly, if I would like to ask someone or you guys, give me water molecules, will you be able to give me one more molecule, 2 molecule or 10 molecule? No. For that I have to use some other unit where we apply moles. At least it will contain 6.02 into 10 to raise by 23 particles. So mole is a much larger number of things. These things can be atoms or molecules or eggs. However, in chemistry we usually use the mole to refer to the amounts of atoms or molecules or ions, etc. I think you guys understand. Okay, let's discuss it another way. Although the number of things in a mole is known to 8 decimal places, okay, it is usually fine to use only 2 or 3 decimal places in calculations. Understand? It is very important. Okay, the number of moles can be known up to 8 decimal places, but we usually take is up to 2 or 3 decimal places to keep our calculations accurate and doable. Okay, and as I have already discussed, the numerical value of mole is called Avogadro's number. Okay, is called Avogadro's number, which is also known as Avogadro's constant, after the scientist named Amadeo Avogadro, an Italian chemist who first proposed its importance. Okay, and as I have discussed earlier, its value is 6.02 into 10 to raise power 23. Okay, where here I have mentioned already, its value is 6.02 into 10 to raise power 23 particles, which can be atoms, ions, molecules, or formula units in 1 mole of that particular species. In 1 mole of that particular species. Understand? So now I would like to discuss the mole in a more depth. We can say at species level. How we can express the mole at species level. Okay. So actually what I mentioned in very first definition, that is atomic mass, molecular mass, ionic mass or formula mass of a substance. Which substance? Atomic mass for atoms, molecular mass for molecules, ionic mass for ions, and formula mass for ionic compounds. The difference is clear, the difference. Okay, so when these are expressed in grams, is called mole of that substance. Now I am going to discuss this one by one. Okay, so you get the complete knowledge how these terms relates with mole. Okay, now and how we can calculate it also discuss here. Okay, so let's move forward. We are here now. The following are different terms and example which will explain the mole concept or mole chemistry with mole units in easiest and explanatory way. Yes, it is very important. I would like to clear your concepts at higher level, my dear students. Okay, actually you don't have introduction with me in detail. You know me till now as your instructor. Yes, I have 22 years of teaching chemistry, and I have been teaching the more than 20 plus nationalities, both offline and online, in chemistry since 1999. More than 22 years. Okay, 22 years. So I would like to explain the easiest way it is possible using the digital technology, because we are not in, you are not in front of me physically. I am not using any board here, okay, whiteboard or blackboard. So I am using my just laptop screen, and I have compiled notes for you. These notes I will also share with you guys. Okay, so trying to explain as much as possible, and still if you have any confusion you can write to me through contact us form and through social media. Ask any question, no issue. Okay, and share with your class fellows, your friends, your relatives these courses, and hopefully we will keep all these courses free of cost on chemistryskills.com. Okay, so now we will discuss the concept of mole one by one through for atoms, for molecules, for ions, and formula units. So very first what I am going to discuss with you is the term gram atom. Actually it is the mole of atomic masses of atoms. Actually atomic masses of atom when represented in gram, atomic mass of an element expressed in gram, very important, is called gram atomic mass or gram atom or mole of the element. Very simple, very simple. Okay, what atomic mass of an element expressed in grams is called gram atomic mass or gram atom or mole of the element. How? Let's take an example. Let's take an example, my dear students. Okay, here the very first example. We know that the atomic mass of hydrogen is 1.008 AMU. Atomic mass unit is not mentioned here, but it is atomic mass unit. Okay. Okay, leave it. AMU. Okay, now atomic mass of hydrogen is 1.008. 1 gram atom of hydrogen, what it will be as per the definition we just discussed above. What? Atomic mass of an element expressed in grams is called gram atomic mass or gram atom or mole of the element. Am I right? Okay, so atomic mass here in this particular example, atomic mass of hydrogen is 1.008 AMU. If I would like to take its 1 gram atom of hydrogen, I will represent this atomic mass here in gram. So it will become equal to mole, 1 mole. Okay. So whenever someone say we have 1 mole of hydrogen atoms, we have 1 mole of hydrogen atom, or if someone asks us, as because we are a chemist, we are studying chemistry, so we are a chemist right now, so being a chemist, the people can ask, a layman can ask us, oh, please give me 1 mole of hydrogen atoms. So what we will do, how much hydrogen atoms we will give him? We will give him 1.008 grams of hydrogen atoms. That will be equal to 1 mole. Did you get it? Hopefully you will get it. 1.008 grams will be equal to 1 mole. Understand? So now let's take another example. Similarly, a very standard example here. What? Carbon. As we know, the atomic mass of carbon is 12.000 AMU. Okay. And if someone asks us, oh, guy, please give me 1 mole of carbon, then what we will do? We know that the atomic mass of carbon is 12. So what we will do? We will represent it in grams. So 12 grams of carbon atoms will be equal to 1 mole of carbon. Will be equal to 1 mole of carbon. Interesting? But I think now you have come to know. Okay, now let's move towards next example. Atomic mass of magnesium is 24 AMU. How much is 24 AMU? And if we will like to take 1 mole of magnesium, what we will do? 1 gram atom of magnesium, which is actually 1 mole. So what we will do? We do the molar atomic mass of magnesium equal to grams. So 24 grams of magnesium will be equal to 1 mole of magnesium. 1 mole of magnesium. Understand? So I think it is clear from the above that 1 gram atom or different elements have different masses. Okay, let's discuss a formula. I have compiled a simplified formula for gram atoms or mole of an element. This is the most simplified formula you can use to find out number of gram atoms or moles of an element. What? No, the mass of element in grams divided by molar or atomic mass of the element. Molar or atomic mass of the element. Let's say someone asked me, I have 46 grams of sodium, Na. Okay, how many moles are there? Okay, what we will do? As per this formula, very simple formula. Mass of the element in grams. What is the mass? 46 grams. So 46 divided by molar or atomic mass of the element. Which is the element? Sodium. So what is this molar atomic mass? 23. You have to study periodic table also. I'll share my periodic table related course here soon. So 46 over 23 will give us number of moles or gram atoms of sodium. How simple is that? So it will be equal to mind math tells me 2 moles of which? Of sodium. We have 2 moles of sodium. Isn't it simple? Hopefully so. You guys got the concept. So let's move forward. Let's see. Now we will discuss gram molecule. Just like gram atom, we will discuss gram molecule. Now we will discuss this term at molecular level. Earlier we discussed at elemental level for taking their atoms. Okay, now we will discuss it at molecular level taking their molecule. Now it becomes gram molecule instead of gram atom for molecules. So what we can say, the molecular mass of a substance expressed in grams. Same. At elemental level, what we discuss, the atomic mass of a substance expressed in grams, but here the molecular mass expressed in grams is called gram molecule or gram mass molecule or mole of that molecular substance. Mole of that molecular substance. I think you guys understand. Mole of that molecular substance. Let's take an example here, guys. Now let me know, please. Very simple. The molecular mass of hydrogen molecule here, not H single, it is H2, which represents the hydrogen molecule. It is 2.016 AMU. 2.016 AMU. Okay, and now this is the molecular mass of hydrogen molecule. So its 1 gram molecule will be equal to the 2.016 grams, which is actually equal to 1 mole of hydrogen molecule. And if someone asks us, please give me 1 mole of hydrogen molecule, so what we will do? We will give him 2.016 grams of hydrogen molecule H2. Isn't it simple? Isn't it simple? Understand? Let's take another example. Now, there is one mistake is looking to be. Oh, this is not here. Okay. Now, what guys? Molar mass of H2 is 18 AMU. Molar mass of H2O. What is H2? Water is 18 AMU, and we have to make it 1 mole. What we will do? We will take 18 grams. We will put gram, represent it in grams, its molar mass, which is molecular mass in grams. It will become 1 mole of water. So if I'll ask you guys, oh John, give me 1 mole of water, please, what you will do? You will take 18 grams of water and give me. Very simple. Whether you are John, you are Johnny, okay, whether you are Tina, whoever is taking this class. So you guys will give me 18 grams of water. Very simple. Similarly, in case of carbon dioxide, its molecular mass is 44 AMU, and its 1 mole will become equal to 44 grams. So 1 mole of carbon dioxide is 44 grams of carbon dioxide. So very simple, guys. Okay, now let's move ahead for its formula. It is clear from the above that 1 gram molecule of different molecules justify that different substances have different masses. Okay, now let's discuss its formula. What is the formula actually? The number of gram molecules, which is actually mole of a substance, molecular substance. Similarly, the mass of molecular substance in grams divided by molar or molecular mass of the substance. Okay, understand? So let's take an example. Okay, let's take an example. I have 90 grams. I have 90 grams of water. H2O. How many moles will be there? 90 grams of water, how many moles or gram molecules will be there? So we will use this formula. What is this mass of molecular substance in grams? How many grams? 90. So we will put 90 above. Okay. Divided by molar or molecular mass of the substance. What is our substance? Our substance is water. Okay. Now what's its molar mass? We just learned that it is 18. So 90 will be divided by 18, and if I use my mind math, it will become equal to 5 moles. 5 moles of water in 90 grams of water. Isn't it simple, guys? Hopefully you got the idea. Now let's move towards the next. Similarly, we can discuss gram formula for formula units of ionic compound. What it would be? The formula mass of an ionic compound expressed in grams is called gram formula, or mole of the ionic substance, ionic compound, mole of the ionic compound. So for an example, just an example, okay, let's take the example of NaCl. Its formula mass is 58.5 AMU. Okay, so it means its molar mass is also same. So when we will put grams here, when we will put grams here, so 1 mole of NaCl will be equal to 58.5 grams. Similarly, the formula mass of sodium hydroxide is 40 AMU. And if we like to take 1 mole of sodium hydroxide, it will be equal to 40 grams of sodium hydroxide. That will give us 1 mole. Okay, now if we would like to express it in terms of formula, the same mass of ionic substance in grams over molar or formula mass of the ionic substance, it means, let's say we have, let's say we have 120 grams of NaOH. Okay, so how many moles will be there? So very simple. What we will do, mass or ionic substance of ionic substance in grams, which is 120. So what we will do, we will put 120 here, divided by molar mass of the, or formula mass of the ionic substance. The formula mass or molar mass of sodium hydroxide is 40. Okay, so I'll put 40 here, and as per my mind math, it will be 3 will be answer. But 3 will be answer. 3 moles of what? NaOH. From what? 120 grams. So 120 grams of NaOH give us 3 moles of NaOH. Understand, guys? Good. Now let's go towards our last definition for this lesson, which is gram ion. Okay, similarly, exactly same. What it would be? The ionic mass of ionic species expressed in grams. Ionic mass of an ionic species. It can be sodium ion, it can be chloride ion, okay, it can be hydroxide ion, etc. When we will represent their masses in grams, okay, it will call as gram ion or mole of that ion, or mole of that ion. Very simple, same, exactly same, guys. So let's say the ionic mass of sodium ion is 23 AMU. So what will be 1 mole of sodium ions? What will be its mass? It will be 23 grams. Okay. Similarly, the ionic mass of hydroxide ion is 17 AMU. So its 1 mole will contain 17 grams. Okay, similarly, if we would like to use its formula, okay, the same formula as we have used for the other species, but the number of gram ions or mole of an ionic species will be equal to mass of ionic species over molar or ionic mass of ionic species. The mass of ionic species in grams, okay, grams. So let's say we have 51 grams of OH ions. How many? 51 grams of which? OH ion. Okay, we have 51 grams of OH ion. How many moles will be there? So as per formula, mass of ionic species is 51. We will put 51, okay, divided by what is the molar or ionic mass of the ionic species? What is the ionic mass of OH? It is 17. Good. So divided by 17. Okay, so as per my mind math, it will be equal to 3. So we will get 3 moles of OH ions from 51 grams of OH ions. Yeah. Or if we would like to take 3 moles of OH ions, what we will take? We will take 51 grams of OH ions. So I hope guys you have got the concept of mole.